let's look at some of the DNS records using the dig utility. First of all, these are the main record types we want to look at. So we have A records, which are the address records, the quad A or the AAAA records, which are the IPv6 address records. You have your CNAME, which is canonical name, which is basically alias records, your mail exchange records, your name server records, your pointer records, or your reverse DNS records. You have your text records, which are used for doing your sender policy framework for keeping track of who's allowed to send mail. You have your service records and your start of authority records. So let's go ahead and look at each of these. In order to use dig, you need to install it. So on my Ubuntu machine right here, I would do a sudo apt install bind 9 utils. Sometimes you can just do bind utils, but this is bind 9 utils. And I put in my password, and it will go ahead and, if I type my password incorrectly, then it'll go ahead and install the package. All right, so now I've got the packages all installed, and I can go ahead and do my dig command. So let's clear the screen. So the first record I want to look at is the A record. So the way you do it is you do a dig, and you tell it the name of the server you want to do a dig on. So if I do Amazon.com, it will automatically default to using an A record. Now, if there's something else, then maybe you'll get something else first. So you can see what it says right here in my response is, in this question section, I asked for an A record. It said Amazon.com was what I was asking the A record about. And the answer section, it says, well, these are the A records that we are returning from the server. Now, this number 900 indicates the time to live for that record. So it wants me to keep that record for 900 seconds. 900 seconds is roughly 15 minutes. And these are the IP addresses that it translates to. So you're taking a host name or a name, and you're converting it into an IP address. You can also see the query time. It says it took me 21 milliseconds. The server I talked to was my localhost machine on port 53 using UDP. All right, so there's some interesting information there. If I wanted to explicitly say that I wanted the A record, I could do a -T for type and A, and it will ask for the A record explicitly. All right, so now we know how to do an A record lookup. What about an AAA record? So I can do -T, add a bunch of A's there, and do google.com. All right, now this returns an AAAA record. So this is the IPv6 address. So google.com, it wants me to keep it for 5 minutes or 300 seconds. It's the AAAA record, and you can see this is the IPv6 address that it translates to. All right, so that's useful. Next, let's look at a CNAME record. Now, I went to the University of Oregon, and let's see what they have. If I do a dig and mail.uoregon.edu, it says, okay, this is my answer section. Mail.uoregon.edu is not an A record. It's actually a CNAME record right here. And it goes to this exchange.uoregon.edu thing. And then it gives me the A record in addition to that. If I wanted just the CNAME record, I could explicitly state I wanted just the CNAME right here with a -T, CNAME, and then it'll give me just the CNAME. You can see that mail.uoregon.edu points to this exchange13uoregon.edu address, and then I have to then do an additional lookup to figure out what this thing is. And that might be a CNAME, it might be an A record, but we already know from above that it was, in fact, an A record right here. All right, so there you can see how to do the CNAME or alias records, canonical name alias records. One of the nice things you can also do at this point is say, well, let's jump back to the Amazon.com thing. And you got this Amazon.com, and I want to know the A record. And I hit this right here, but maybe I want more information. I want to know, where does this get it? Maybe it's not return the A record. I want to figure out what's happening. I could do a plus trace. Plus trace will start from the root servers and work my way down, all the way down to the record. You can see right here, it starts out right here. It asks for the dot. It goes to the dot servers, and these servers are listed right here. And then these servers will then tell me how to get information about the Amazon.com domain. Well, what they do is they tell me to go to these COM records right here. So I go to these COM servers and I ask them about Amazon.com. And then what they do, scroll down a little bit, is they redirect me over to these NS servers over at Amazon. So you got these Amazon DNS orgs and stuff like that. And so all these DNS servers are providing DNS for Amazon.com. And so then those servers respond with this right here, my A records. They also give me the name server records as well, just to let me know how to get this information. So trace is good. Sometimes you have situations where somehow something isn't moved correctly, or you're moving a domain from one server to another server, and you can get information problems there. All right, so that's trace. Let's do the other one that's kind of fun, is short. And short says, okay, I want to dig up these ones right here, and I do the short. Instead of giving me all the information, it just goes straight to the answers, and there you go. All right, let's go to the next step. Let's say I know this IP address, and let's say that I'm communicating with this, and I start wondering, what is this address? I could do a dig -x, and then the IP address right there, and it tells me right here that what I'm looking up is the pointer record, the PTR record. And you can look at this address right here, and it's 103.242.251.205.in-adder.arpa. Now that can be a little bit confusing, but it does make sense when you think about it. So what you're looking at always in an address is the very last part is the largest portion. So the dot is the largest, ARPA is the next largest, the in-adder is the next largest, and then you work your way all the way up to the front, where this is the least significant on the front, just like in a normal domain name. Dot ARPA dot. All right, so then you can look that up, and you can see it right there. So kind of long, just to verify this, and you can tell what's actually happening. When I did the -x, I could type in the address in normal order. It's right here, and you can see the 103 was on the end. And then when it did the pointer record, it converted it right here, and the 103 is on this end, on the left-hand side. All right, so there's pointer records and the -x option to make it easier to view it. Now, if I want to send mail, I use Gmail a lot, so I can do a dig -tmx gmail.com. And what does this tell me? Well, this tells me the mail servers that receive email. Now, this one's a little longer. You can see Gmail servers. You can see the time to live. You can see it's an MX record type. And then you see this thing right here. This is a priority number. So what does it mean? Well, it means that you always want to pick the one with the lowest number. So you're not doing this yourself. I mean, that happens by the mail servers in the background. But that means you connect to port 25 on this machine right here, and you will send mail to this one for gmail.com. Now, the rule is officially, if this one does not respond, you can try the next one, which would be this 10. And if that one does not respond, you can try the next one. So I think you can try 3 different servers. At that point, you were supposed to stop officially and just not do anymore. So you should never hit this one right here, and you should never hit this one right here. And if you do hit them, then you're likely a spammer. Just so you know, that's one way you can identify spammers. And you attempt to send mail that way. All right. So now when Google is sending out mail, sometimes it's good to know who is allowed to send the mail. So they have another thing called the SPF record, or the sender framework thing, and you can use the TXT records to see which ones they are. So if I do gmail.com, this will ask who is allowed to send mail from gmail.com or in behalf of gmail.com. And you can see the answer is, all right, so the people who are allowed to send it is SPF or underscore SPF.google.com are the only ones allowed to send mail for Gmail. Well, that's interesting. So who is that? Well, you can do another lookup right here and do underscore SPF dot and then change this to google.com and see who is allowed to send mail. Well, it says, okay, we actually have a couple different network blocks. We have this network blocks.google.com, and we got netblocks 2, and we got netblocks 3. Okay, so that's fine. And then no one else is allowed to. So this tilde all means all others are excluded. So you say, okay, fine, we want to see what they are. So let's look at netblocks. Netblocks. We got netblocks 2 and 3. And you can see, oh, okay, these are the network address blocks. So this range can send it, and this range can send it, and you can kind of see how it goes down and decides who is allowed to send mail for Google. And you could also look at the next set right here, the blocks 2, and you can see, yeah, these ones can send it to these IPv6 addresses, and the netblocks 3, and it says, and these other addresses are also allowed to send mail for Google. So you can use the TXT message for your SPF records right here, and then define who is allowed to send mail. So that's nice. All right. Another thing we like to do is look up service records. So service records, so you do a dig -t srv, and this will be a service record. Typically, you do not directly type in the service records, and they're handled by different services in the background. So you got xmpp-client dot underscore tcp dot jabber org. So what is the service record for that? Well, it says, all right, so for this service, you know, a TCP-based service for the Jabber client, we're going to have a priority await, and then we have the port number right here. This is the port number on scarlet.jabber.org that receives the Jabber client. And so that's how you can direct things to specific port numbers and have them find things. So that's kind of nice. It's kind of like a more universal use, kind of like the MX director, where you can decide which one to redirect to and help you out there. All right. Now we saw these earlier, but there's the NS records. So if I do a dig -t NS, and let's go ahead and type in microsoft.com, you can see these are the machines that are the name servers for Microsoft.com, or the ones that are name servers that we can see from where we are at. So it says, okay, these are the answers. And it also provides additional section right here and says, oh, by the way, this particular one right here, this .com one, has this IP address. So you can use this one too. So we want to recommend this one. So then if you want to look up Microsoft.com stuff, you can use this IP address. Well, how do you do that? Well, let's say I want to look it up. And you can see every time I've been doing a lookup, it has this IP address right here as the IP address I'm looking up from, which is great, but that's my own machine. So if I do a dig at, I can tell it which machine or which one I want to use. So I can do right here, paste that, and I can do Microsoft.com. And it says, okay, these are the Microsoft.coms. Now, I could also change it to a different DNS server. Google provides a public one at 8.8.8.8. And I can look that up here, and it provides a maybe different list. Maybe it's the same list. At least the order is different. But then you can get the information there. You can see this time it's responding from this server. So you can tell it which server to use using the @ name right there. The last record I wanted to mention is the start of authority record. So if I do -t SOA and let's look up google.com, it says, all right, here is my start of authority. So you can see that google.com got 5 minutes, or actually 1 minute, 60 seconds. You have a start of authority record right here, and this is the name server that does start of authority. This right here is actually an email address, and the way it works is it's DNS-admin, and this part right here, you change this dot into an @ sign, google.com, and that is the one that received mail for this domain. The next number right here is your serial number for the information for the record. So that's the serial number. This right here is your so you can look at the SOA record, figure out if it's newer, and if it is newer, you can try doing a zone transfer. Now, Google will not allow me to do a zone transfer, but if I wanted to do one, I could do a dig -t AXFR and google.com, and it will try to perform a transfer. And Google says, nope, you can't transfer our DNS information. But if if someone left their DNS open, maybe they could give you it. And then maybe you could transfer all this information. They'd be like, wait a second. Now you can see all of our stuff, and we're all vulnerable. Anyway, I hope this helps you with the dig utility and figuring out how to use it. And good luck.